Okay, YouTube, in this video we're going to look at another application of a determinant. That is the test to see if 3 points in the xy coordinate plane are collinear. And recall that collinear points just means that these are 3 points that are all lying on the same line. So I suppose that if we were to look at this, with respect to the xy coordinate plane, I think that this would be a good sketch to make. So I'm going to assume that all of our points lie in the first quadrant here. Actually, because I'm just going to assume that, I'm just going to draw the first quadrant kind of like this here. But let's assume that we have 3 points here. And we'll call this one x1, y1, x2, y2, and x3, y3. And just to make it easy for ourselves here, I'm going to put them all 3 in a row. But let's say that they do indeed lie on this line. Then what I would say, I suppose, about this is, knowing what we know about this formula here that we used in our last video for the area of a triangle. Let's take a look at this here. We say if we knew the 3 points that represent the vertices of this triangle, then its area is always plus or minus 1/2 times this determinant here, where we have our 3 ordered pairs here and we filled in the last column with 1s here. But essentially, if this area here, consider if we had a triangle here formed by these 3 points, what would be the area of that triangle? And so we, I guess, identify that the area here of that triangle would be 0. So what we can say from that, I guess, is this. We say that we have that the area of a triangle cast as, given, or I guess having these 3 vertices here, we would say is plus or minus 1/2 times that determinant that we had listed before. But the fact of the matter, I guess, is this. If the area is equal to 0, then these 3 points are collinear. And so what we're essentially doing is we're allowing the area to be 0 here and saying that these 3 points in here, if we put it in and find its determinant and it comes out to be 0, then plus or minus 1/2 times 0 would be that 0. So essentially what I can tell you is, because all I want to know is, does this come out to be 0 or not, to test to see if they are collinear, then I don't have to pay attention to this half here. And so what you're seeing essentially here is this. We're saying that the area, which was this part right here, we're saying if it's 0, then these points are collinear. So are these 0 when you find the determinant? That would be the test here. We're just neglecting the half. So we're going to use the same formula we used on the last one. Essentially, we're going to drop in our 3 ordered pairs here. We want to know, are they all on the same line? And so you might guess here, I hope, are they on the same line? We say -2, -2, 1, 1, 7, 5. Does that fit the pattern? Not really. So looking at this here, we ask, does it equal 0? That's the question here. Because if it does, then the area of that triangle is 0. But if the area of that triangle is 0, then we have 3 collinear points. So what we're going to do is we're going to find the determinant here, get its value, say -2 and -2, 1 and 1, 7 and 5. We'll go ahead and do this pretty quickly here. So we'd say down diagonals minus up diagonals here. We have -2 times 1 times 1 is -2 plus -2 times 1 times 7. -2 times 7 would be -14 here. Plus now 1 times 1 times 5, which is 5. Now going through our up diagonals, 7 times a couple of 1s there is 7. Plus 5 times, well, really -2, we get -10. Plus now really -2. So when we find these sums and then find their differences, so we say our difference, we say -16 plus a positive 5 is -11. And we have, let's see, a -3, and a -3 plus a -2 is a -5. So something like this, we would add the opposite, of course, and we would get -6 here. So -6 is what we get. So what is our conclusion? And my conclusion would simply be this. I suppose I could just type it in this time because my handwriting is really bad. So we say that the conclusion would be that these points are not collinear. Now, why do I say that they're not collinear? And I want you to consider this here. The area here would not be -6. It'd be plus or minus 1/2 times -6. But the idea is you didn't get 0. And if it were 0, then these would all have to be on the same line. So these points are not collinear, but because we have a non-zero triangular region area. And that's really why they are not collinear in this particular case. So did you get a determinant of 0 or not when you find this particular matrix's determinant? Cheers.